Okay, so good morning, everyone. Good morning, good morning. Welcome to our day three of our Astron Energy Spring Schools for 2024. Now, guys, before I start, I just want to say a big fat welcome to everyone and a big fat thank you for taking time out of your very busy schedules to attend our maths lessons. Guys, today we are starting with math paper one. So I hope we all are as excited as I am today because maths is the best subject to do. Now, guys, before I start, before I get into the lesson, we obviously know that there are some ground rules, okay? For those of you who don't know, my name is Philip Engelbrecht. I was the guy who took you for physics paper one, all right? So I'm the guy who covers the paper one exams, okay? Now, guys, today is obviously maths paper one, but I think all of us can notice that our mics and our cameras have been disabled. Guys, we do that for a reason. We do that so there are no distractions in the lesson. Okay, I do not want to hear your mom shout at you to clean the dishes during this lesson. Okay, so that's why I've switched off the mics and cameras. However, if you have a question that you would like to ask, you may raise your hand or you may post it in the chat. All right, we'll do our best to answer all of your questions. All right, now before we carry on, can everyone please state their name, their school, and the number of people watching that lesson at their device? So if you are watching this lesson at home, you just put your name, your school, and you put the number one. All right. If you are a teacher who is presenting this lesson to their class, you put your name, your school, and the number of kids in the class. Okay. Guys, this is just for our record keeping purposes. Okay. Now, just a reminder, these lessons will be recorded and we will make them available at a later stage by the end of the day today. Okay, we'll try our best to make the video for today as well as yesterday's video available at the end of the day. Okay, now, guys, one more thing and one more very, very important thing. Please remember that this is a learning environment. Okay. So if you have a question, no matter how silly you might think that question is, I encourage you to ask that question. Okay. Because you never know. That same question that you're busy thinking of is the same question that 20 or 100 other people are thinking of. Okay. So, guys, please do not be shy to ask questions. All right. And number two, which is also very important, for those of you who are at our physics lessons, you know that we like to ask you guys to try and attempt some of these questions. And I love to try and give you guys the hardest questions. Okay, so guys, please, I encourage you to try and answer these questions and interact in the lesson. Okay, I will give you some time to attempt some of these problems. Please, guys, at the end of the day, it's for your own benefit. If you are just going to sit and stare at the screen and photosynthesize, you're not actually going to learn much, okay? The more you engage in the lesson, the more you actually take something away from this lesson, okay? So, guys, please, please, please try and answer these questions. Even if you get it wrong, it's not a train smash. We will go through the right answer. And if you still don't understand, you can ask me, okay? Now, let's get started. Guys, we all know that maths is the best subject because it's the easiest subject that you do in high school, okay? Maths, I always say maths is like the easiest subject to study for. Why? Because unlike all the other subjects like life sciences and history and all of that, you don't have to remember a lot of stuff. You just have to practice. Other subjects, they like to test how good you are at remembering, and then they make you vomit it out on a piece of paper. Guys, in maths, you just have to practice. And the more you practice, the better you become. So, like I said, maths is the easiest subject to study for. Okay. And I'm sure you guys can all agree with that. So, let's get started. Guys, before we even start to answer questions, make sure you read that instructions, okay? Because if you do not read the instructions, you might make a mistake and you can lose marks. So, number one, it says this question paper consists of about 10 questions. They say answer all the questions. Guys, please try your best to answer all the questions. Clearly show all calculations, okay? You can't just write one word answers, okay? And before it says one answers will not necessarily be awarded full marks. So guys, if you have a 6 mark question and you just put the answer down, you might only get 1 out of 6. Okay. Make sure you show you're working out. Okay. a rule of thumb is if the answer is for 2 marks, that usually means you can just put the answer down, okay? If it's for anything more, you have to do your calculations, okay? You may use your scientific calculator, okay? If necessary, round off answers to 2 decimal places, okay? Please, guys, do that. If you do not round off properly, they can deduct marks. Diagrams are not necessarily drawn to scale, so that means, especially for geometry, you can't just use your protractor to figure out what that angle is, okay? Because they are not actually drawn to scale, okay? They have number 8 says your information sheet with all the formulas provided. Number the questions correctly. And number 10, the most important one, guys, write neatly and legibly. Meaning, guys, do not scribble down your answers, okay? Because if you scribble down your answers, your examiners who have been marking 10 other papers or 100 other papers before they get to your paper is going to be so gutful, they are just going to mark it wrong, okay? So please make sure you write it neatly, okay? Because if they struggle to read your answers, they just go, nope, I'm not going to read through this. Wrong. Remember that. Okay, let's get to question 1. Guys, question 1 is your algebra. All right, this should be the part of the test where you get the most marks if you practice, okay? So, let's start. 1.1 says solve for x, and 1.1.1 says 3x squared plus 5x is equal to 0. And for a simple 2 marks. So what do? Well, let's see. What is common in my 3x squared and my 5x squared? What is common? X is common. Look, I have a 3x squared and I have a 5x. Thank you guys for answering that for me. So therefore, I can factor out an x, and I'm left with 3x plus 5, is equal to 0. Now, here's the thing. You have something multiplied by something else that is equal to 0. That means that either x is equal to 0 or the other bracket, which is 3x plus 5, is equal to 0. So therefore, x is equal to 0, or you solve for this and you get that x is equal to negative 5 over 3. And those are your 2 options. Now, guys, thank you for answering unverified. Your answer is completely verified. Well done. Here's the thing, guys. This is a mistake that many people make. If you have, for argument's sake, 5x times 3x plus 5 is equal to 10. That doesn't mean that 5x is equal to 10 or 3x plus 5 is equal to 10. No. Guys, no. You never do that. You only do it if it's equal to 0. Okay? If it's equal to some other number, then you're going to have to take that number to the other side and solve for it, and then you can figure out what x is. But if you have a bracket times the bracket is equal to 0, then you can do this technique over here. If it's equal to anything else, you never use it. Please remember that. That's a mistake that many people make. Okay? Try and avoid that mistake because you will lose an unnecessary amount of marks. Okay? And with marking in math, if your mathematical technique is wrong, all right, so if you do it wrong, then they just mark it wrong completely, and anything below that is just wrong. Okay? So please, guys. Okay. 1.1.2 says 4x squared plus 3x minus 5 is equal to 0. And look, guys, they've given you a clue. They say answer correct to 2 decimal places. So when they say that, that immediately tells me I need to use the quadratic formula. Okay? So that therefore means that x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Okay? So therefore, x. Now, what is my a? This is a, remember? This positive 3 is b, and this negative 5. Guys, please do not forget the signs in front of your symbols. This negative 5 is c. So this is equal to negative 3 plus or minus the square root of 3 squared minus 4 times a is 4. And c is negative 5. Don't forget that, because if you didn't put negative 5, you would have probably gotten a math error, right? Divided by 2 times a, which is 4. You do this on your calculator and you get that x is equal to 0.8 or x is equal to negative 1.55. And those are your two solutions, okay? Pretty easy. This was, 5 marks on the plate so far. So 5 out of 150. We are doing well. Now, 1.1.3 is an inequality. It says 1 minus x squared in brackets minus 9 is greater than or equal to 0. So what do? I multiply this bracket out. So this becomes x squared, right? Now what you do is you go product of these two. So you go negative 1 times x is negative x. And then you multiply it by 2. So this becomes minus 2x plus 1. Negative 1 squared is positive 1. Minus 9 is greater than or equal to 0. All right. Yeah, thank you for answering that. So therefore, we simplify this. It becomes x squared minus 2x minus 8 is greater than or equal to 0. Now you factorize. So you go, okay, what are the factors of 8 that if I multiply them together, I will get a negative 8. And if I add them together, I will get negative 2. So hopefully you guys are quite good with factorizing. So this will be x minus 4, x plus 2. Because negative 4 times positive 2 gives me negative 8. Negative 4 plus 2 gives me negative 2 is greater than or equal to 0. Now, what do I do next? Who can tell me what do I do next when I see this? I draw my number line, okay? So you draw your number line and you put in what they call your critical values, okay? So your one critical value is negative 2. The other one is positive 4. And then what you can do is, what I like to do, you just draw your little parabola, because technically it's like this. These are the roots of your parabola, okay? Now here's the thing. We want to know for which values of x will this whole thing be greater than 0. So basically, guys, what they're asking is, for which values of x will this thing be above or equal to this x-axis over here, okay? So for which values of x will this be greater than 0? Well, it's here and here. Now, if I go less than 2, you see that this function is above my x-axis. If I go greater than 4, it's above my x-axis. So I can write it like this. I can say x must be less than 2 or x can be greater than 4. And now I'll go, okay, what was the original question asking? We were saying greater than or equal to. So that means that x can be equal, less than or equal to 2, or x can be greater than or equal to 4. That's the one way you can write it, okay? The other way is, number 2, you can say, for those of you who get taught in the set theory way, you can say that x is in between negative infinity and 2, and I use the square brackets because I'm including 2, or, and you use that union sign, it can be 4 square brackets or positive infinity. That's a very ugly infinity, but that's infinity, like that. So guys, these are the two ways in which you could have written your answer, okay? I think most of us get taught this way, number 1, but I know some kids do get taught number 2 as well, all right? So those are your two ways in which you can actually represent your answer. Don't do both, just do one, okay? Pick one and stick with one, okay? Hopefully we understand that. Hopefully there's no questions. I did see someone ask, sir, can you send the 9 to the other side and root both sides? You can, however, okay. Hopefully we understand this. I'm going to show you the other way. The other way you must just be a little bit awake for. I'm going to change the color. I don't want to use black. I'm going to use another color. So you can say that x minus 1 squared is greater than or equal to 9. Then you take the square root of both sides, okay? Yeah. So then you say x minus 1 is greater than or equal to 3, or x minus 1 is less than or equal to negative 3. So what happens? The one side becomes 3, the other side flips, and it becomes less than or equal to negative 3. You solve for this and you get that x will be greater than or equal to 4, or x will be less than or equal to negative 2, because you just add 1 on both sides, okay? Plus 1, okay? Does that make sense? You can do it like that, but it would look like this. So that is your answer, guys. X is greater than or equal to 4, or x is less than or equal to negative 2. The other way you could have written it, okay, if you do not know how to write it, guys, just don't write it, okay? But some kids are taught like that. It's called the set theory way. And that is saying x is less than or equal to negative 2. Well, then it's in between negative infinity, okay, and negative 2. And I'm going to put a square bracket because I'm including negative 2. I'll put a curly bracket because I'm not including infinity, okay? And then I say or, and the way you say or is this upside down u, or just a normal u, is not upside down, sorry. Then I say positive 4 or positive infinity, and I use the curly brackets, okay? So those are the two ways, number 1 and number 2, okay? Like I said, if you do not know how to do the number 2 way, don't do it, guys. You will just confuse yourself. Moving on. 1.1.4 says 5 to the power of 2x minus 5x is equal to 0. All right? So what can I do now? Well, I'm going to do it like this. You need to remember your exponent laws. If I have a to the power of 2x, that's the same as saying a to the power of x times a to the power of x. Because remember, if your bases are the same and you multiply them, you just add the exponents. So this becomes 5x times 5x minus 5 to the power of x is equal to 0. Now what's common in everything? 5x. So I can factor out a 5 to the power of x. Sorry guys, it's 5 to the power of x. And I get that this is 1 minus 5 to the power of, oh, sorry. Oops, I am now losing a bit of focus here. Oops, I made a bit of a mistake. Give me a second. Okay, so remember, I factor out of 5x, and I'm left with 5x minus 1 is equal to 0. Again, you have something times something equal to 0. So therefore, either 5x is equal to 0, or 5 to the power of x minus 1 is equal to 0. Now, guys, here's the thing. 5 to the power of anything will never give me a value that's 0 or less than 0, okay? So here, there's no solution. No solution, right? Okay? Just trust me on that. 5 to the power of anything, whether it's plus 1 or negative 2 million, will never, ever give you a value that's 0 or negative, okay? Over here, this becomes 5 to the power of x is equal to 1. So therefore, x, anything to the power of 0 will give you 1. So therefore, x is equal to 0. And there are my two answers, guys. It's either no solution or the x is equal to 0. Okay. Just curious, could I not have used the k method? Yes, you could have said let 5 to the power of x equal k, and then it would have been 5 to the power of 2x would have been k squared, okay? So you could have also used the k method, guys. There is no problem, or you could have used this method, okay? Moving on. 1.1.5 says x over the square root of 20 minus x is equal to 1, and we have to find the values for x. Now, guys, ek is nou 'n bietjie moeg gepraat. I've spoken enough, okay? So, you guys are going to attempt this question, all right? Can't we just drop the basins? So that only works if you multiply, not when there's a minus, okay? So someone said, can't we just drop the base? No. All right, that only works if you multiply. But when it's, so if I have 5x times, or 5x is equal to 5x is equal to 5 to the power of 3 minus x, then you can say x is equal to 3 minus x. But if it's 5 plus or minus, you don't do that, okay? So guys, for 1.1.5, so like I said, let me just rub this out again. Okay. if I have something like this, 5x times 5 to the power of 3x is equal to 5 to the power of 10, then you can say, therefore, because the bases are the same, I can say x plus 3x is equal to 10. Okay? That's what you can say. All right? So, guys, for those of you who solve it, I will give you 5 minutes to try and attempt this. When you do this, you can post your answer in the chat, okay? So for those of you who haven't attempted it, you guys can attempt it now. For the rest of you who have tried this at home, you can post your answers in the chat. Okay, guys, so I've seen everyone is posting their answers, so let's figure out. I'm seeing x is equal to 4. Some people are saying x is negative 5 or 4. Let's see what the answer is. So what I do is I'm going to multiply both sides by the square root of 20 over x, and you get that x is equal to the square root of 20 minus x. All right? And what I do is, to get rid of that radical, or that square root, I square both sides. And I get that x squared is equal to 20 minus x. I take everything to the other side, and I get that x squared plus x minus 20 is equal to 0. Then you just factorize. So therefore, this becomes x. Well, the factors of 20, that if I add them together, I get 1. And if I multiply, I get negative 20. So that's simply x plus 5, right? X minus 4. And that makes sense. Positive 5 times negative 4 is negative 20. 5 minus 4 is 1, is equal to 0. And therefore, x is equal to 5, or x is equal to negative 4. I'm done, right? Here's the thing. Here is the thing, guys. You are not done. And I'll give you a clue. Whenever you answer a question that has a square root, your final step is you need to go test that answer. So you need to go test. So I'm going to test x is equal to, sorry, that's negative 5, positive 4. I do beg your pardon. X is equal to negative 5. And you type that on your calculator, and if you do that, your answer becomes negative 1. Okay? So negative 5 divided by the square root of 20 minus negative 5, you get negative 1. That's a bit of an issue because our answer needs to be 1. If I test that x is equal to 4, the answer becomes 1. So guys, I can reject x is equal to negative 5. So therefore, x is equal to 4. Okay? There we go. All right. Thank you for getting that right. All right. Okay, guys, let's move on. 1.2 is almost always your simultaneous equations, and there are your two equations. X plus y is equal to 9, and 2x squared minus y squared is equal to 7. Now, there are many different ways you can solve simultaneous equations. My personal way is I get this side to be y is equal. So I say y is equal to 9 minus x. And what I do is I substitute it in there. So therefore, 2x squared minus 9 minus x squared is equal to 7. Right? So that becomes 2x squared minus, remember, you keep your brackets. You only take away that brackets at the very end. So 9 squared, that's 81. 9 times negative x is negative 9x times 2 is minus 18x plus x squared is equal to 7. So this becomes 2x squared minus 81 plus 18x, all right, minus x squared is equal to 7. All right. So now, guys, you just simplify this a little bit. So this becomes, if you simplify, this becomes x squared plus 18x minus 88 is equal to 0. So what are the factors of 88 that if you add them together, you get positive 18, and if you multiply them, you get negative 88. And I got that this is x plus 22 and x minus 4. 22 times 4, or 22 times negative 4 is negative 88. 22 minus 4 is 18. Therefore, guys, x is simply equal to negative 22, or x is equal to positive 4. Now, what you do, guys, you take both of those values, you substitute it into the other equations, and therefore you get that y is equal to 31, or y is equal to 5. And those are your two solutions. Okay, well done. All right, guys. So remember, so someone asked, sir, can you please explain the previous question again? Okay. So I assume we all know how we got the negative 5 and the positive 4. I think we all know how we get that. But here's the thing, guys. The square root of any value is always above 0, okay? You never, ever get a negative value if you take the square root of something, all right? That is the simplest way, okay? So if you get that, if you test this, and your answer, and you have a square root, and your answer is negative, okay, it means that there's something wrong, okay? So just remember, the square root of any number is always positive. So whenever you answer a question in algebra that tells you to find x, and you see that there's a little square root in there, you make sure you test both of your solutions at the end, all right? Because as you can see, when x is equal to negative 5, there's actually no solution, okay? I hope that makes sense. There we go. All righty. Now, given that P is equal to 1 minus A, and T is equal to 1 plus A, and the rest, determine the value of P times T in terms of A. Now, this is a little one where it would have caught some kids out. It almost like caught me out, but what I like to do with these ones is I like to play around with them, guys. When I see them, I say, okay, what can I do? What can I see? What patterns can I see? What can I do? And what I did was I said, okay, let's find out what is P times T. Well, that is simply 1 minus A, right, for P, and T is simply 1 plus A, 1 plus A squared, 1 plus A to the power of 4, and that goes all the way to 1 plus A to the power of 512, okay? That's what I do. Now, what patterns can I see? What do I notice here? Well, hopefully, you guys all notice this. What does this look like? You guys can answer that for me in the chat. What does this tell you? This is something that we have learned, I think, in grade 11 already. So guys, what is that? You can answer that in the chat for me. What does that look like to you guys? Dots. Oh, man. There we go. Dineo. Difference between two squares. Well done. All right. So, difference between two squares. So, this becomes 1 minus, because 1 squared is 1, minus A squared. All right. Plus 1 plus A squared, 1 plus A to the power of 4, dot, 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 all the way to 1 plus A to the power of 512. All right. Again, let's look over here. What do I see here again? I again see difference between two squares. So this becomes 1, because 1 squared is that. A squared, if you square it again, that becomes A to the power of 4 times 1 plus A to the power of 4, dot, 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 all the way to 1 plus A to the power of 512. Guys, do you see a pattern? I think we can all see a pattern. It keeps doing this, difference between two squares. And if you keep doing that, you're eventually going to get 1 minus A to the power of 512 multiplied by 1 plus A to the power of 512. Again, this is difference between two squares. So all of those other brackets get to something like this. And therefore, P times T is simply equal to the value of this, which is 1 minus a. Now 512, or a to the power of 512, if you square it, becomes 1024. And there is our final answer. Okay, guys? So hopefully we can understand that. Okay. So remember over here, I don't know if you can see the pattern, but just keep seeing it's difference between two squares the whole time, okay? And you're gonna keep doing that. And if you keep doing that, you're gonna end up with 1 minus a to the power of 512 multiplied by that very, very last value, which was 1 plus a to the power of 512. Then your final step, remember again, this whole thing is difference between two squares. So therefore, you write it. Remember, 1 squared is 1. A to the power of 512 squared. That just becomes, remember, if you have ax squared, that becomes a to the power of 2x. So a to the power of 512 squared becomes a to the power of 2 times 512. And that is how we get the 1024. Okay, does that make sense, guys? All right, if you do circle a bit to understand, you might just want to replay this video again, because we are going to make the videos available. And you also just might have to try and answer the question yourself. Because what I've also learned is, when I see a new question that I kind of get but kind of don't get, I try and actually answer that question myself again without any help. And then I do it and I say, okay, now it makes sense. Okay, guys, so you just might have to replay this video and attempt this question on your own, but it wasn't that bad. Okay. So moving on. So this was 1.3, and now we are done with question 1. Question 2. Now question 2, I automatically know is your sequences and your series. All right. So let's see what we have to do. Let's go. Given the series, and this is 4 plus 2 plus 1 plus a half, dot, 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 all the way till infinity. And we have to consider this. This is a geometric series. How do I know that? Because they have told me that. All right. So let's change to red. 2.1.1 asks, does this series converge? And you have to justify your answer. So guys, can anyone tell me, how do I know if a series converges or not? Who can tell me? How do I know? Or what does it mean? Who can tell me first? What does it mean if a series converges? Okay, so we know that a series converges if R is in between -1 and 1. But guys, what does it mean? What does it mean if a series converges? Okay. Okay, so we know it converges when R is in between -1 and 1. But I don't know what does converge mean? Someone can answer that for me quickly. Let's see. Okay, repeating, gets infinitely smaller. Okay. Okay, I see. Okay, so guys, if a series converges, that means that if you were to add up all those infinite terms, you will get a proper number. It will not just add up to infinity, okay? So if you have, for instance, this geometric series, it means that if you were to add up all these terms that extended until infinity, you would actually get a proper number out of it, okay? You will not get some large infinite number. You will get a number. It will add up to a specific number. Okay, so that's what it means if a series converges. All those little terms add up and they give you a proper answer. They give you a number. They give you an answer. Okay, so for a series to converge, we know that the ratio needs to be in between -1 and +1. So how do I find the ratio? Remember, the ratio is always your second term over your first term. Okay, or Tn divided by your previous term. So what's my second term? My second term is 2. My first term is 4. So therefore, my ratio is 1/4. Oops. 1/2, sorry. So that is my ratio. My ratio is a half. So what does that mean? Because 1/2 is in between -1 and +1, the series will converge. So therefore, the series converges. Okay? 1.1.2 says, calculate the sum to infinity. So now I know that the series converges. So what does that tell me? That means that if I were to add up all these values, it would give me an answer, right? It will not give me infinity. So we all know that the sum to infinity is a divided by 1 minus r. Now, guys, what is a? Remember, a is not always term 1. It's where we started, okay? In this case, where did we start? We started at 4. So that becomes 4 divided by 1 minus r. Now, r is 1/2. So 1 minus 1/2 is 1/2. And therefore, the sum to infinity is 8. And there we go. So what does it mean, guys? What does the sum to infinity equal to 8 mean? That means that if I were to add 4 plus 2 plus 1 plus 1/2 all the way into infinity, if I were to add all these numbers together, the answer would be 8. All right? Because as you get to infinity, your number becomes so small, it's virtually 0. Okay, so if you were to add up all these terms, you get 8. All right? I hope you understand. 4 easy marks on a plate for these two questions. Now we say, given the following term, the sum uh, of 3p to 3 to the power of p minus 1, starting at p is equal to k and ending at p is equal to 10, all right, is equal to 29,520. Determine the value of p. So we have to find out what is our starting point, all right? So remember, you guys can do this, okay? So someone says, so what does mean it isn't always the first term? All right. So what I mean is it's not term 1. All right. That's what I mean. A does not always equal term 1. All right. It's where we start. That's kind of what I meant. Okay. It's where you start. Sometimes a pattern we start at term 2 and not at term 1. All right. So remember term 1 does not always equal to A. In many cases it does, but in other cases it does not. Okay. So guys, here is your pattern. All right, so we know that the sum to the first 10 terms starting at p equal to k of 3 to the power of p minus 1 is equal to 29,520. And we need to find out what is our starting point. All right, so guys, it's for 5 marks. I'm going to give you 5 minutes to try and solve this one, okay? It looks scary, it looks difficult, but I'm going to show you it's not, these questions are not as difficult as they might appear. So guys, you have 5 minutes. Please post your answers in the chat. And if it's wrong, no one really cares, guys. We are going to get to the right answer, okay? So your 5 minutes starts now. Okay, guys, so I'm seeing a lot of answers here. I'm seeing k is equal to 10, k is equal to 3, k is equal to 1. Some person said 5 minutes is too long. Hey, well, I'll give people time to answer. Kind of funny because that person didn't even post their answer, but you know, that's just me. K is equal to 3, k is equal to 10. Okay, so it seems like we are divided with the answers. Okay, well, I can say some people got it right. Okay, so let's figure out the answer. All right, so what I'm going to do is I'm just going to take this away. Now, this is what we have been given. All right, when you see this, firstly, this is, I think we can all agree this is a geometric series. All right, we can all agree with that. How do I know that? Because it's 3 to the power of p minus 1. Okay, that immediately tells me that this is geometric. Okay, what is the sum of a geometric series? I know that Sn is equal to a to multiply by r to the power of n minus 1 divided by r minus 1. Okay, that's the first thing I know, right? So when you're answering this question, that's the first thing that you need to write down. Now I need to find 3 things. I need to find a, I need to find r, and I need to find the value of n. Okay, so those are the 3 things I need to figure out. Okay, well, I'm going to first start with r. Okay, and the way you do that is, what I like to do with these things, I just find the first 3 terms. Okay, so term 1, that's just simply 3 to the power of 1 minus 1. That's 3 to the power of 0, which is just 1. Term 2, that becomes 3 squared minus 1, which is just 3. And the answer becomes 3. Term 2, that becomes 3 to the power of 3 minus 1. That becomes 3 squared, which is 9. So how do I go from 1 to 3? I multiply by 3. How do I go from 3 to 9? I multiply by 3. So I can immediately tell that R is 3. Okay, that's the first thing I have down. Check. A. Now, what is A? If you think A is your first term, you are wrong. A is where we started. That is why I said, guys, A is not necessarily term 1, okay? So, I'm just going to rub this out. Rub, 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 rub. Rub it out, rub it, rub. Okay, so let's find out what A is, all right? Remember, A is where we started. Where did we start this pattern? At P is equal to K. So therefore, A is simply 3 to the power of K minus 1. Okay, so that is 3 to the power of K minus 1. So I have K and I have R. Now I need to find N. Okay, so I'm going to erase this again. Now, here's the thing. I don't know if you guys were taught this, all right? I know I don't think I was taught this in school. Maybe I just didn't listen. I forgot. Your N value is not this number on top, guys. It's not 10. It's always the top minus the bottom, and then you add 1. So therefore, N becomes top, which is 10, minus the bottom. What is the bottom? K. And then you add a 1, right? Just like that. Now, here's the thing, okay? This is the part where you just had to, like, spot something. Can we see that we have a K minus 1 here? All right? Now, I don't know if it will happen, actually, but I have a feeling that this K minus 1, I can make this one look a little bit similar to that. All right? How do I do that? Well, I'm going to say this is 10, and I'm going to factor out a negative 1, okay? And I'm left with K minus 1, okay? Because I kind of want those two to be similar, because maybe during my calculations, it might cancel out. I do not know that, but I'm just going to keep it like this, just so it looks a little bit neater, okay? So, those are what we have so far. Let me just get my eraser out to make this look a little bit neater. So, I know that A is equal to 3 to the power of K minus 1, R is equal to 3, and finally, N is 10 minus k minus 1, okay? You didn't have to do that, but for me, it just makes it look a little bit neater. And you never know, maybe during the calculations, these might cancel out. I'm not sure, but just to keep it like that. So therefore, what does that mean? That means that therefore, Sn is equal to A, which is 3 to the power of k minus 1, multiplied, and in your brackets, R is simply 3, N is 10 minus k minus 1, okay, minus 1, divided by R minus 1, that's simply 2, all right? Now, what is the sum of your terms? That was 29,520. That becomes 29,520 is equal to 3 to the power of k minus 1. Now, here's the thing. I have 3 to the power of 10 minus that bracket. If you remember your exponents, a to the power of x minus y is the same as saying a to the power of x divided by a to the power of y, okay? I don't know if you remember that from your exponent laws, okay? But that is how you can write it. So this 3 to the power of 10 minus that bracket, I can just rewrite it as 3 to the power of 10 divided by 3 to the power of k minus 1 minus 1 divided by 2. Okay, I hope everyone's on board with me. Okay, so we all understand that. Can you guys give a thumbs up or a thumbs down? Do we all understand how I got to this part? Okay, perfect. Now, because remember, this is R minus 1. R was 3, and 3 minus 1 is 2. So that's how I got 2 at the bottom. Okay. Now, I just have to solve for k. This becomes simple algebra. So what I do is I multiply both sides by 2, and I get that 59,040 is equal to 3 to the power of k minus 1 multiplied by 3 to the power of 10 divided by 3 to the power of k minus 1 minus 1. Oops. All right. Now what I do is I simply multiply it out. All right. So I multiply this into my brackets. Now look over here. 3 to the power of k minus 1 multiplied by 3 to the power of 10 divided by 3 to the power of k minus 1. Guys, these are just going to cancel, and I'm left with 3 to the power of 10 minus 3 to the power of k minus 1. And that's equal to 59,040. What I do, I carry on solving it. So I take this 3 to the power of 10 other side, and if you type this on your calculator, you get that negative 9 is equal to negative 3 to the power of k minus 1. So I divide both sides by negative 1, and I also know that 9 is 3 squared is equal to 3 to the power of k minus 1. Now let's look over here. My bases are the same, so therefore my exponents should be the same. So therefore 2 is equal to k minus 1. And finally, guys, that therefore means if I take the 1 to the other side, that therefore means that k is equal to 3. And Bob's your uncle. Okay, so for those of you who got k is equal to 3, well done. Okay, so someone said, why is it divided by 2? Do you understand now? Remember, this became, let me just rewrite this, okay? I'll just add it in over here. This became 59040 minus 3 to the power of 10, and that's equal to negative 3k minus 1. And if you type that on your calculator, you get negative 9. All right? Okay. So I'm just going to go back over here. Guys, do we understand how I got this? Okay? Do we understand how I got this equation first? Okay. Yes, no, maybe. You guys can answer in the chat. No. Okay, okay. Okay. Let me just get out my highlighter. So here's the thing. I know immediately that I'm dealing with a geometric pattern. All right. How do I know that? Because I can see it's 3 to the power of p minus 1. That's the first thing I know, okay? I hope you guys are listening. What is the sum of n terms for a geometric pattern? It is this equation over here. This is the equation that's given to you at the back of your formula sheet. I hope you guys understand that, okay? Now, here's the thing. I need to find three things. I need to find what A is, I need to find what R is, and I need to find what N is, okay? So, I need three things to find. I need to find A, R, and N, okay? So, A is my starting point, okay? It's where I started the whole thing, all right? Where did I start? I started here at P is equal to K. So I rewrite my equation. I say 3, but instead of saying P, I say K minus 1 because I substituted in K, okay? So my starting point is 3 to the power of K minus 1, okay? Or, while I wrote down, you basically write down your first three terms, and you figured out that R was 3, okay? Because term 1 was 1, term 2 was 3, and term 3 was 9. So you can see the pattern. Your common ratio is 3, okay? Now, N. N was the part where you would have to think a bit, okay? Remember, N is your top of that sigma symbol minus the bottom, and you add 1. So N became 10 minus K plus 1. Now what I did was, for that minus K plus 1, I factored out a negative 1, and I got that K, so I got 10 minus, and in brackets, I got K minus 1, okay? The reason why I did that was just so that, you know, it might be able to cancel out a little bit later in my calculations, okay? Here's the thing. All you had to do now was you substitute it into your equation. So for A, I got that A was 3 to the power of K minus 1, okay? For R was 3, and remember N was 10 to the power of K minus 1. Your denominator is R minus 1, so that becomes 3 minus 1, which is 2. That's how I got 2. Now, here's the thing. 3 to the power of 10 minus that bracket. If you remember from your exponents, a to the power of x minus y is the same as saying a to the power of x divided by a to the power of y. Okay? So that 3 to the power of 10 minus your bracket can be simplified to 3 to the power of 10 divided by 3 to the power of K minus 1. I hope we understand that. Do we all understand how I got to that equation now? Okay, if you don't, we just might have to replay the video. Perfect. I see we understand. Now, guys, it became basic algebra, okay? So your first step was you had to multiply both sides by 2, and 29,520, if you multiply it by 2, you get this, 59,040, okay? Right, and that was equal to 3 to the power of K minus 1 multiplied in brackets by 3 to the power of 10 divided by 3 to the power of K minus 1 minus 1, okay? Now, here's the thing, okay? You multiply that 3 to the power of K minus 1, you multiply it into your brackets, okay? And this would have cancelled because you have something. If you multiply 3 to the power of 10 divided by 3 to the power of K minus 1, if you multiply it with this, they would cancel because 1 is in the top, 1 is in the bottom, so they cancel each other out. So this, we would have just been left with 3 to the power of 10 minus, well, 1 times this will just give you 3 to the power of K minus 1. And guys, this just became basic algebra. All right, I took this 3 to the power of 10 the other side. I got negative 9 is equal to 3 to the power of K minus 1. I divided both sides by negative 1 to make them both positive, and I know that 9 is 3 squared is equal to 3 to the power of K minus 1. And because my bases are the same, it means my exponents have to be the same. So therefore, 2 is equal to K minus 1. and therefore you solve for this and you get k is equal to 3. Do we understand now? Okay, do you guys understand how I got it now? Perfect. Okay, guys, I hope you guys understand. Thank you, guys. Hope you guys can understand a little bit better now. Okay, perfect. Let's move on. So that was question 2 done. Let's get to question 3. Alrighty, let's just take my highlighter away. Oops, get out my pen. Perfect. Now it says consider the quadratic number pattern. And they gave 3, 7, 12, dot, dot, dot. 3.1.1 asks, show that the general term of this number pattern is given by that pattern, that term over there. All right. So let's go. We have 3, 7, 12, dot, dot, dot. I know this is a quadratic number pattern. So I know I'm going to have a first difference as well as a second difference. All right. So let's figure out what is the first difference. So 7 minus 3, that is 4. 12 minus 7, that is 5. So this is the first difference, guys. Now we find the second difference, because the second difference stays the same. The first difference changes, but your second difference always remains the same. So what is my second difference? Well, it's simple. 4 minus 5 is 1. So here's my first difference. Here's my second difference. Now I can find the values for my general term. So I know that 2a, all right, so this is something that you should have learned. 2a is always equal to the second difference. Okay, so therefore, a is equal to, 2a is equal to our second difference, which is 1. So therefore, a is equal to a half. All right, so I already have this. I already have a. Now I need to find b. Okay, remember, b is like this. You say 3a plus b is equal to the first number of your first difference. So the first number of first difference. Okay, so therefore 3a plus b is equal to 4. All right. Now I substitute it in, so that becomes 3 over 1 over 2. Or sorry, 3 multiplied by 1 over 2 plus b is equal to 4. You solve for this, so this becomes 4 minus 3 over 2. That's 8 over 2 minus 3. That becomes 5 over 2. So therefore, b is equal to 5 over 2. Bam. So we have a, we have b. Now we need to find c. So remember, a plus b plus c must always give you your first term over there. All right. So a was 3 over 2. Oh, sorry. 1 over 2 plus 5 over 2 plus c is equal to 3. Now a half plus 5 over 2, that becomes 6 over 2, which is 3. So I'll say that therefore 3 plus c is equal to 3. So therefore c is equal to 0. Bam. And they are our solutions. Okay, guys? So a is a half, b is 5 over 2, and c is 0. Okay, and therefore your general term is a half n squared plus 5 over 2n plus 0, or just plus 5 over 2n. Okay, I hope you understand that this is a nice simple one. Okay, now it says what number must be added to tn minus 1 so that tn is equal to 13,527. Guys, I am going to give you 4 minutes to try and answer this question for me. So what number must I add to my previous term so that my next term is equal to 13,527? So guys, I will give you a few minutes to try and attempt this question, okay? So you got your time starts now. Okay, guys, so I am back. So I see some nice answers. I see answers around 160, and I see a very big number of 13,524. Okay, so let's see, what is the question asking? Remember, in math, it also tests how well you can read and comprehend, okay? So they're asking, what number must be added to Tn minus 1 so that Tn is equal to that number? So what is it asking? It's saying, what number must I add to the previous term so that this next term is equal to 13,000? Okay, I hope that makes sense. So let's figure it out. Now, I first want to figure out when I answered this question, I was like, okay, what value for n will this give me? Will Tn be 13,520? So I want to know, for which value of n will this be equal to 13,527? All right. So what I do, I say 13,527 is equal to, now what was my general term? It was a half n squared plus 5 over 2n. Okay. Now what I do is I solve for n. So I get that 0 is equal to 1 over 2n squared plus 5 over 2n minus 13,527. And guys, you can just use your calculator for this. You do that and you get that n is equal to 162, or n is equal to negative 167. Now, guys, when you're dealing with term patterns, you don't ever deal with the negative term, okay? So therefore, my value for n is 162, because n must always be positive, okay? So I ignore the negative. Now, I'm not done, okay? What's the question asking? It's asking what must be added to the previous term so that the next term is 13,527. So what is the previous term? All right, if my Tn was the 162nd term, the previous term, so therefore my previous term is n is equal to 161. So this is the term before 162, okay? So what is the value for term 161, okay? What is the value? All you do, guys, you type it in on your calculator, all right? So this becomes 1 over 2 times 161 squared plus 5 over 2 times 161. You type this on your calculator and you get that term. 161 is 13,363. All right, so that's the previous term. All right, so what must be added to 13,363 to give me 13,527? So therefore, what must be added? You simply take term 162 minus term 161. And if you type that on your calculator, that becomes 164. All right. So it means that I must add 164 to my previous term so that the next term is equal to 13,527. Does that make sense, guys? Okay, so well done for the people, Joshua, the other people who got 164. All right. Remember, you just had to read it very, very carefully. All right. Okay, I'm glad we got it, guys. So, next, okay, given an arithmetic sequence with term 1 is equal to 8 and term 2 is equal to 11, calculate the value of n if Tn is equal to 41. So, guys, I know that term 1 is 8, term 2 is 11. So what I'm going to do is I'm going to try and find what the pattern is first. Okay, before I go anywhere else, I find what the pattern is. So term 1 is equal to a plus n minus 1 times the difference. Remember, that's the general formula for a pattern. But in this case, for term 1, n is equal to 1, right? So this becomes 1 minus 1, which is 0. So therefore, term 1 is just equal to a, and I know that a is simply 8, all right? Because we started at term 1. Term 2 is equal to A, which is 8, plus n minus 1 times the difference. All right? So, what is this? Well, term 2 is 11 is equal to 8 plus 2 minus 1 times the difference. You solve for this, you get that therefore D is equal to 3. So this is your common difference. All right? So that therefore means that your pattern is equal to 8 plus n minus 1 times the difference, which is 3. What I need to now do is I need to figure out for which values of n will the Tn be 41. All right? So guys, then you say that 41 is equal to 8 plus n minus 1 times 3. All right? 41 minus 8, that's 33, is equal to n minus 1 times 3. 33 divided by 3, that's 11, is equal to n minus 1. So therefore, n is equal to 12. So for those of you who got 12, well done. You see, guys, maths, am I moving a bit too fast? I will slow down, okay? You see, guys, maths is not that difficult. You just have to read it carefully, okay? But do we know how we got to this answer, okay? You just had to firstly find what the pattern was. And when you found the pattern, you just said Tn is equal to 41, and you found the values of n, which gave you 41. And because it's arithmetic, it's only one value, okay, which is 12. Okay, do we all understand? I hope we do. Perfect. Don't worry, guys, I will slow down a bit for the next one. Yeah, so I just want to read it because I can't really read too well over there. So it says over here, for 3.2.2, it says, a new arithmetic sequence P is formed using the term position and the term value of the given arithmetic sequence. For the new sequence, P8 is equal to 1 and P11 is equal to 2. So guys, what have they done here? They've just swapped the stuff around, all right? So A says, write down the value of P41. Okay, so guys, what is the value for P41? Who can tell me? Remember, they're just swapping the stuff around. Well done. It's 12. Okay, how do I know? Remember, term 1 was 8. Term 2 was 11. So what they've done now, they just swapped the stuff around. So therefore, P8 is simply 1. P11 is 2. All right. So what I'm going to say is, okay, what is the pattern for this? Okay. Now, guys, there might have been a different way other people have done it, but what I simply did was I said that P Tn is equal to n. All right. So they want to know what is the value for P41. All right. So I go, okay, P41, so Tn is equal to 41. So therefore, what will the value of n be? I'll ask myself, for which values of n will I get 41? And the answer is 12. All right. If you get asked P8, what's the value of P8? Remember, okay, this is Tn. All right. So Tn is equal to 8. So I need to ask myself, for which values of n will I get 8? If you figure it out, the answer is 1. So therefore, it's 1. Okay? Does that make sense? Are you guys with me for this so long? All right? Does that make sense? So all you do is you just swap the terms around. Okay? Yeah, if you don't understand it, it is a little bit of a tricky one. So remember, the sequence or the general formula for this pattern is simply P Tn is equal to n. So if I have, for instance, what is the answer for P41? Well, over here, I know that this 41 is equal to Tn, and I need to figure out what the value of n is. Okay? So now you ask yourselves, for which value of n will Tn be 41? Okay, and remember, what was Tn? Tn was 8 plus n minus 1 times 3. So when this is equal to 41, then you go 41 is equal to 8 plus n minus 1 times 3. You solve for it, and therefore you get that n is equal to 12. So therefore, the answer for this is 12. Okay, guys? The same if you had, for instance, P8. If I had to ask you now, what is the value for P8? You go, okay, this is Tn. So Tn is equal to 8. So now you ask yourself, for which values of n will I get 8? So you say that 8 is equal to 8 plus n minus 1 times the difference. And if you do that, you get your answer, n is equal to 1. So therefore, the value of P8 is 1. Okay? Do we understand this? All right, so the value for P41 is simply 12. Okay? Do we understand this, guys? You guys can give a thumbs up or a thumbs down if you don't understand. Okay, perfect. So now, part B says, calculate the first value of the new arithmetic sequence. So they want to know, what is the value of P1? Can you guys try and solve that for me? I'm going to give you 2 minutes, okay, to try and figure that out for me. What is the value for P1? And I'm going to give you a clue. Remember, Tn is equal to n. So here, Tn is equal to 1. So what is the value for n? You guys have 2 minutes, starting now. Okay, so I've seen a few answers. If you guys are still busy, you can just post your answers in the chat. But remember, I know that Tn is equal to 1. So that therefore means, oops, that therefore means that 1 is equal to 8 plus n minus 1 times 3. Okay, so therefore, you take the 8 to the other side. 1 minus 8, that is negative 7 plus, negative 7 is equal to 3 to the power of n minus 1. So therefore, n minus 1 is equal to negative 7 over 3. So therefore, n is equal to, you take the 1 to the other side, it's negative 7 over 3 plus 1, and therefore that gives you negative 4 over 3. All right? So therefore, P1 is equal to negative 4 over 3. And Bob is your uncle. Guys, do we understand how we got that? All right? Do we understand? Perfect. Okay. Okay, you just had to think a little bit outside the box with this one, but I'm glad we all understand that. Remember, I do not mind re-explaining the things. I get paid to do this. So, next question. Question 4. We are almost done before we take our break. So, they say given that g of x is 1 divided by x minus 1 plus 2. Okay, that's what they've given us. Okay, that's the equation of our graph. What type of graph is this? Is this a parabola or a straight line? Or what type of graph is this? Okay, what type of graph is this? A hyperbole. Okay, very good, guys. It's pronounced hyperbole, all right? Or hyperbola, not hyperbola, okay? So it's hyperbola, okay? I used to say hyperbola at school, and parabola. It's parabola, hyperbola, okay? Well done, guys. So write down the equations of the asymptotes of G. Well, let's look over here. This plus 2 means that y, it means that the graph firstly moved up by 2, but it also means that y is equal to positive 2, okay? That's the first one, done. All right. The second one, right? Remember, they're asking for the equations, not the points, okay? The second one is asking we have to find out the x value, all right? So x will be equal to, now remember, guys, that minus 1 means it moves 1 unit right, not left, okay? So that x is equal to positive 1, okay? Please remember that. For the y value, if it's minus 2 or plus 2, you write y is equal to minus 2 or plus 2. That stays the same. If it's x minus 1, that means that the equation for the asymptote is x is equal to positive 1. So the x's, the signs for the x's swap, but the signs for the y stays the same. Yes, if it was x plus 1 in the denominator, then the equation for your x asymptote would have been x is equal to negative 1. All right? So remember that always just swap. Okay? Moving on. So draw the graph and indicate any x-intercepts and any x and y-intercepts and indicate the asymptotes. All right? So step 1 is when you ever have to draw a graph, you have to find your x and your y-intercepts first. So remember, for your x-intercept, all right, you make y equals 0. Okay? So what does that mean? That therefore means that 0 is equal to 1 over x minus 1 plus 2. So negative 2 is equal to 1 over x minus 1. And guys, what you do, you simply solve for this. So that becomes negative 2 times x minus 1 is equal to 1. All right. So therefore, x minus 1 is equal to negative 1 over 2. So therefore, we type this in and you solve for this. You type it on your calculator if you don't want to do hard math, and you get that x is 3 over 2. Bam. So I know that my first intercept is going to be somewhere here. 3 over 2. Okay? Now we have to find our y-intercept. Our y-intercept, remember, for your y-intercept, you make x equals 0. Bam. So that then means that y is equal to 1 over 0 minus 1 plus 2. That just becomes negative 1 plus 2. And therefore, for your y-intercept, y is equal to 1. So therefore, it's somewhere over here. All right? So I'm going to clear the ink off the slides. So we know that the x-intercept is something over here. 3 over 2. And we know the y-intercept is somewhere over here, and that's 1. All right? Now we can put in, someone said, sir, it's 1 over 2. Where did we get that? Let's just check. Are we sure? Are we sure, guys? Let's just check again. So we got that 2, oh, sorry, negative 2 is equal to x minus 1. Therefore, yeah, you guys are right. It's 1 over 2. I wrote it wrong. You guys are absolutely correct. Yes. So it's 1/2, and over here is 1. Okay. Now we have found our x. Thank you for pointing that out, guys. So now we have found our x-intercept and we have found our y-intercept. Remember, for a hyperbola, you also need to indicate your asymptotes. So here are my asymptotes. For my y value, y is equal to 2. For my x value, it's x is equal to 1. All right, so I'm just going to move this x-intercept like that. Okay, so over here, 1 over 2. So we have found our asymptotes. We know what our asymptotes are. We have found our x and our y intercepts. Now we can draw a graph. But here's the thing. Is it here or is it here? If a is above 0, so remember, if I take it to this one, it's this 1 over here. So if that 1 was positive, it means it's this and that. If a is less than 0, then it's like that. Okay, guys? So let me just clear it out. I know that a is positive, so my graph is going to look something like this. Here's the first one, and here's the second one. Okay? So my graph looks something like this, and it intercepts the y-axis at 1 and the x-axis at a half. And this is y is equal to 2, and finally x is equal to 1. All right? So guys, that is our graph. All right? Sorry for that mistake about the x-intercept. I do apologize, but there we go. All right. Now let's move on. That's a very simple graph. There we go. Now it says, determine the values of x where g of x is greater than 0. All right, and that's for 2 marks. So guys, I want you to type it on your chat for me. So show me the value, or type the values of x for which g of x is greater than 0. Okay, so you guys may type that in the chat. Okay, so I'm seeing very good answers here. Okay, so let's see what the answer is. So I'm going to take you back to my graph, okay? Because they actually expected you to interpret the graph, all right? So let me just take out my highlighter. So we want to know for which values of x will this graph be greater than 0? So what does that mean? What does it mean if it's greater than 0? In simple terms, I want to know for which values of x will this function be above my x-axis, all right? So let's look over here. Where is this graph above my x-axis? Give me a highlighter, sorry, highlighter. Well, it's over here. Here, it's definitely above my x-axis because here's my x-axis. And over here, well, if I go past or to the left of 1, it's below until I get to a half. Then when I move past a half, you can see it's above the x-axis. All right. So that therefore means that firstly, x can be, I can say that x can be greater than 1 because look here, if I'm any value that's bigger than 1 going to the right, my function will forever be above the x-axis. Or I can say that x must be less than a half, because if I go past or to the left of my half, I see that my function is above the x-axis. So there you can say that x is either greater than 1 or x is less than a half. For the other people who get taught the set theory way, so this is 1, you can write it in set notation, and you can say that x is an element of, and you can say negative infinity and a half, or 1 and positive infinity, okay? So guys, these are your 2 answers. Like I said, if you are not taught set notation, don't even worry about the second method, okay? It only applies to the kids who are taught to represent their answers like this. Okay, that's a pretty simple one. And then it says, determine the equation of the axis of symmetry for which G has my reading is not the best today. Determine the equation of the axis of symmetry of G, which has a negative gradient. So guys, your axis of symmetry is a line that goes through the midpoint of these asymptotes, or where they meet. So they meet at the point 1 and 2. Okay, so that's this point over here where they meet. And we want an axis of symmetry that has a negative gradient. So a negative gradient means it looks something like that. Okay, that's a positive gradient. I do apologize. Negative gradient means it looks something like, change my color, like that. Bam. Okay. So we want to know what is the equation of that straight line like that. Okay. So someone asked, should it not have square brackets on the numbers? No. A square bracket means that you are including those numbers. Okay. And the question asks, for which values will g of x be greater than 0, not equal to? Okay. If it was equal to 0, then you would have used the square brackets on a half and on 1. Okay. Hope that answered your question. Anyways, so let's solve this problem quickly. So I know that the point where they meet, so the point where the asymptotes meet is the point 1 and 2, right? And I want it for a negative gradient. So yeah. So therefore, I'll say that y is equal to negative x plus c. All right. Remember, they said a negative gradient. Okay. And then finally, I substitute that point 1 and 2. So I get that 2 is equal to negative 1 plus c. And therefore, c is equal to 3, positive 3. And therefore, my equation y is equal to negative x plus 3. Bam. Okay. There we go. Very easy to marks. Okay. Perfect. I see everyone who posted in the chat got it right, except for one person who said x plus 2. But I think it was just a silly additional error. Don't worry, guys. It does happen. So 4.4 done. And we are done with question 4. Now we just have one more question before we take our break. Okay, so just hang in there. We are almost done. So it says in the diagram, graphs f of x, which is the log base a of x, and g are drawn. Graph G is the reflection of f in the line y is equal to x. So I immediately know graph G is simply the inverse of x. Why? Because they said it's a reflection in the line y is equal to x. Okay, so I know that graph G of x is the inverse of f of x. Graph x passes through the point P is 4 and 2. And Q is the x-intercept of f, and R is the y-intercept of G. Okay, 5.1 says, write down the coordinates of T prime, which is that little dash, which is the image of P on G. So they want to know what is the value of P prime. Well, what do I know? Okay, I know that G is the reflection of f in the line y is equal to x. So I know that G is simply the inverse of f. All right, because it's a reflection in this line. Y is equal to x. So whatever value I have over here, P prime is simply going to be the inverse of it. So it's just going to swap. All right. So therefore, if point P was 4 and 2, it means that P prime, because G is a reflection and G is the inverse of X, it therefore means that P prime is 2 and 4. Bam. Okay? So, moving on. Hope you understand that it's a pretty easy one. Easy to marks. Moving on. Show that A is equal to 2. All right. So, what do I know? I know that f of x is equal to the log base a of x. All right. And I also know from my previous calculation that p prime is equal to 2 and 4. I might not need it for this equation, but I might need it for other stuff later on in this question. I need to find out what is the value of a, well, I need to show that a is equal to 2, okay? So what I'm going to do is I'm going to substitute any other point on graph F, and I'm going to substitute on P, which is 4 and 2. So that therefore means that 2 is equal to the log base A of 4. Now this is what I do. When I work with logs, what I do to get rid of that logs, I say A squared. So I make both sides the power of A. So I say A squared is equal to A to the power of log base A. Okay? So that means that A squared is equal to, now here's the thing, A to the power of log base A, these just cancel, and I'm left with 4. Okay? So therefore, A squared is equal to 4. So therefore, A is equal to 2. Okay? And there we go. Does that make sense, guys? Do we understand how I got to that? All right? I hope we do. Perfect. Okay, if you don't understand, you can just state in the chat. But if you do understand, you can send a thumbs up if you understand, or a thumbs down if you do not understand. Okay, so someone asked if I can please explain again. No worries. So I had A is equal to the log base A of, sorry, I had 2 is equal to the log base A of X. Okay? Now what I want to do is I want to get rid of this log, okay? The way I do it is I say that A squared, okay? So I make both sides powers of A. So I say that A squared is equal to A to the power of log base A of X, okay? So this side just sticks to A squared. However, this side, A to the power of log base X, they basically cancel, okay? And I'm left with X, okay? And therefore, A is simply the square root of X, okay? Does that make sense? Okay, so I'm just showing you how I got rid of that log, okay? Do we understand how I got rid of it? You guys can say yes or no. Okay, I assume you understand. But yeah, that's just how you get rid of logs, okay? Perfect. So guys, we showed that A was the square root of X and X was 4, so therefore A was 2. And remember with logs, I know the square root of 4 would be plus or minus 4, but with logs, that base must always be positive. You can't take the log with a negative base. So A is positive 2, always. Okay? Perfect. Moving on. All right? Now he says, write the equation, write down the equation of G in the form of Y is equal to dot, dot, dot. So we firstly know that G is equal to the inverse of F. All right, that's what they've told us in the beginning. So here we go. So I know that f of x, for f of x, I know that y is equal to the log base 2 of x. All right, that's what I know. So for my inverse function, all right, what you do is you just swap the y and the x value. So that means that x is equal to the log base 2 of y. And now I want to get rid of this log base 2. So what do? I do it like this. I say 2 to the power of x is equal to 2 to the power of log base 2 of y. This side is going to stay the same. However, 2 to the power of log base 2, they are going to cancel, and I get that 2 to the power of x is equal to y. Okay? So therefore, that is the equation for g of x. Okay, so g of x is equal to 2 to the power of x. Okay, and we got our equation in the form of y is equals. Okay, do we understand this? Okay, do we also understand how I got rid of that log for that person who asked me to explain again? Okay, almost done, guys. We just have one more question and then we're going to take a quick break. All right, so over here for 5.4, it says P is a point on F in the first quadrant. So it means I'm over here. Okay, in this first quadrant. This is the first quadrant, the second quadrant, the third quadrant. Obviously, this is the fourth quadrant, right? If you remember from trigonometry, all right? So I know I'm in the first quadrant. So I'm in this section over here, okay? This one, right? So it says T is a point in the first quadrant where TR is parallel to the x-axis. So it means that R over here, right? So R, this is 0 and 1, and T is parallel to this axis, which means that the Y value for T is going to be the same as the Y value for R. So over here, I know that T is the point X and 1. All right. And they want us to calculate the area of triangle RTP prime, not RTP, RTP prime. Okay. So I know that P prime was somewhere over here. This was P prime, and the value was 2 and 4. So we need to find the area of this triangle over here. Okay. So what do I do first? Okay. You guys can answer that for me. That's what I'm going to do first. I'm going to let you guys try and answer this question for me. You guys have 3 minutes. I'm going to take a minute away. So you guys have 3 minutes to answer this for me, starting now. Okay, guys, so I'm seeing many people are getting the area is 3 units squared, and I see one person even managed to put in the square in that chat over there. So I don't know how you did that, but well done. All right, I don't know how to put that in the chat, so good job on you. Maybe you can even share it with the rest of us. So what, guys, well done. It is 3 units squared. I see someone just said the number 3. Remember, guys, for area volume, you have to put in the units, or otherwise you can actually not get full marks. So for those of you who don't understand how we got to the answer, let me show you. I first need to figure out, I'm going to change it to a lighter color. I first need to figure out, okay, what is the value of x at point T? So I know that point T is x and 1. Okay, so you must press the number 2 for long. Okay, I will do that. Thank you guys for showing us. Okay, now another person also did it. Okay, anyways, guys, I know that T is the point x and 1, and it's on f of x, all right? And just in case we forgot, f of x is equal to the log base 2 of x. So I need to now find what is the value for x, okay? So I know that 1 is equal to the log base 2 of 2. All right? No, sorry. Log base 2 of x. I'm already thinking of the answer. Okay, so I want to get rid of this log base 2. So what do? I say that 2 to the power of 1 is equal to 2 to the power of log base 2 of x. Now look what happens over the on my left-hand side, it just stays 2 to the power of 1. On my right-hand side, 2 cancels with the log base of 2, and I'm left with x. So therefore, t is the point. T is the point 2 and 1. Right, there we go. So I know what t is. So what I'm going to do is I'm just going to clear everything on my slide, and I'm going to redraw this triangle, change it into a darker color. Okay, so this is my triangle. Okay, I know that point R is the point 0 and 1. I know that T is the point 2 and 1 because I've just calculated it. And I know that P prime is the point 2 and 4. So what can I see here, guys? I can see that T and P prime are directly in line above each other. How do I know that? Because they both have the same X value. I know that R and T are on the same plane. How do I know that? Because their Y values are the same. All right? So therefore, I also can tell that this is a 90 degrees because one is perfectly vertical, the other one is perfectly horizontal, which means that it makes a 90-degree angle. Okay? So what can I do now? Well, now I know how to find my area. This is a simple triangle, so area is 1/2 base times height. All right, so that becomes a half. Now, what's the base? The base is RT, and my height is P prime T. Okay, very simple. Now, what is the value for RT? Okay, so this is equal to 1/2. Oops, 1/2 times. So what's RT? Well, how do I go from? I'm only going to focus on the X values, right? Because I'm going from right or left to right. Okay, so if you're going in the horizontal direction, you only worry about your X values. On top of that, they're on the same plane as well. So I'm only going in one horizontal direction. So how do I go from 0 to 2? It's only 2 units. Okay. P prime T, how do I go? Well, because they are have the same X values, I only focus on the Y values. Okay. How do I go from 1 to 4? I go up by 3 units. So this is 3. And therefore, you multiply this with each other, and you get that the area is 3 units squared. Do not forget your units squared. Okay, guys, you can lose marks. There we go. So that is the area of our triangle. Okay. Do we all understand that? Okay. So guys, that is the end of question 5. All right. So we are going to take a break. I know it says 45 minutes. I was planning to finish around 11:15, but I see I finished about 18 minutes earlier. So guys, we are going to take a break for an hour. You guys have an hour break, and we are going to start our next lesson at 12 o'clock. Okay. How do we get a job at Astron? So guys, you must start at the very bottom. So you must start pumping up petrol in the cars and stuff like that, you know, cleaning the windows. And then they make you write a maths test. And if you do well in the maths test, you can teach the lessons. Okay? No, I'm joking, guys. Guys, I work at the Cape Town Science Center, and Astron Energy sponsors the Cape Town Science Center. And one of the projects that they sponsor are extra lessons, masterclasses. Okay? So if you want to do this one day, get a science degree, work at the Cape Town Science Center, and also come join the project. Okay? Just a reminder, guys, you can use the same link for this lesson. Okay? So you guys can leave the chat, exit everything, and rejoin by using the same link for our next lesson. Okay, guys? So guys, take a bit of break, eat a bit of lunch, and then maybe even go over the next few questions, and I'll see you at 12 o'clock. Okay? The next lesson starts at 12 o'clock. Okay, guys? So see you soon, and bye-bye.